Good morning. So, welcome you for one more session on chemistry. So, in last class, we have completed till fourth question, right? So, without wasting a time, we will start the next question number 5. Give the most common oxidation state of lanthanoids. Give the most common oxidation state of lanthanides. Very straight question. So here they are again asking. So last question we have discussed about the actinoids. So now the case is different. Here they have asked about lanthanides. So most common oxidation state means here your answer will be +3, right? Here in lanthanide only one common oxidation state is there, that is +3. That means all the element of lanthanide series, they commonly exhibit +3 oxidation state. So why they are exhibiting means because of their stability, that's all, right? So every element they show their charge positive, either negative or else whatever it may be, +2, -2, huh? or +7, +6. Why they are showing means because to get stable in their what ground or in their atomic state, right? So this is about the oxidation of lanthanoid, right? So next question number 6. Number 6. What is the formula of, this question is very important. What is the formula of product formed? What is the formula of product formed when lanthanide, shall I write directly? Lanthanide means TLN. Lanthanide reacts with number 1 reacts with halogen, right? Number 1 halogen, number 2 nitrogen, number 3 oxygen, and number 4, this question has been asked for 4 marks in number 4 sulfur in 2017, right? And which is very easy if you understand this question, right? So what they have asked is so directly I will say, when lanthanide reacts with halogen means what will be the formula, right? So this is the question. So what they have asked, what is the formula, right? What is the formula of product after reacting lanthanide, after reacting with halogen, for example, what will be the product formula, right? Understood? The question is very simple. So see here, to solve this question, one, we must and should know what is the oxidation, common oxidation state of lanthanide. Just now before we have saw what is the oxidation number of common oxidation number of lanthanide, +3. So thus keeping that in our mind, we have to move, right? So answer will be, see here, number 1 halogen. I will write just beside this only, here only. If lanthanide reacts with halogen, see, very important, halogens are nothing but, you can take any halogen, fluorine, chlorine, bromine, iodine. Astatine is also there, but it is a very rare element. So always, and these elements one we can represent with what, right? with X. Understood? So with X we represent. And what is the charge? In all the halogens we have minus charge. Don't forget. Why? Because we write like this: fluorine, chlorine, bromine, iodine. Right? So with respect to that, these elements can be represented with the X, and thus and they are having a negative charge on it. So therefore, how many negative are there? Minus negative. I mean one negative. So thus, see here, lanthanoid, what it is showing? +3, right? I mean common oxidation state. So if it reacts with halogen means X. With halogen, there are only one negative charge, but this lanthanoid requires how many? 3. So thus, see here, now one lanthanoid, if it reacts with X molecule, then we require how many X molecules? 3 X molecules. This is the formula product, right? So lanthanide, whenever reacts with the halogen, definitely we require 3 mole of halogens. Any halogen you can take: fluorine, chlorine, bromine, iodine, right? So next, nitrogen. So again, for nitrogen also, lanthanide will show definitely what? +3 charge. And now what about nitrogen? Nitrogen will show minus negative charge. Plus how many it requires? +3. And how many it is giving? Definitely 3. So thus they are matching. So what will be the formula of product? LNN, right? Next, oxygen. So now Ln shows +3 and oxygen shows -3. Now the case is very different, right? Why? Because there is one is odd and one is even number. In such cases, what we need to do is we try to match their valencies. I mean oxidation states. Why? Because whenever you give equal number of electron to the electron deficient species, then only that compound will be correct. Otherwise, that compound will be wrong. So now try to bring the oxidation number same, right? So now what we need to do is, see here, if I react this with the 2, I mean if I take 2 oxygens, then 2 2s are 4, -4. But here we require what? +3. So no match. I mean one more extra we will take. 3 2s are what? 6. So now one we can say 6. If 6 will come on this, then we will retain with this 3 only. If it not, then definitely we will move for 4, right? So we will check. So 3 2s are 6. Okay. So now 2 3s are 6, right? So that means how many plus 6? 3 2s are 6. How many minus? 6. So therefore now it is matching. When it is matching, when lanthanides are 2 and oxygens are 3, right? So now what will be the formula of product? So how many Ln we should take to balance the oxygen? 2. And how many oxygen we should take for balancing lanthanoid? 3, right? Ln2O3. Next, sulfur. And here in case of sulfur also the same condition applies like oxygen. Why? Because sulfur can also show -2 and our lanthanoid requires how many? +3. So that therefore directly we can go now. 3 2s are 6 and 2 3s are 6. That means Ln2Es3. So these are the 4 answers. If you give just this answer, then you will get 4 marks very easily, right? So but to solve this type of questions, we require a little bit knowledge about the oxidation states, right? And if you know the lanthanoid oxidation state, then definitely we can very easily solve these type of questions. So now next question, number 7. Actinoid contraction, number 7. Actinoid contraction is greater from element to element, is greater from element to element, then lanthanoid contraction, then lanthanoid contraction. This is just give region type of question. Actinoid contraction is greater from element to element than lanthanoid contraction. See, in actinide also we see the contraction. In lanthanide also we see the contraction. But what he is asking is nothing but, so both the series are giving what contractions. But in actinoid contraction is greater as compared to the lanthanoid. Why? This is the simple question. So actinoid contraction is greater from element to element, but lanthanoid does not show that much of contraction. Why? He is asking. That means very simple question. Why? Because here 5f orbital have poorer shielding effect, right? About shielding effect I have already explained you. As we move from S to P, shielding effect decreases. From P to D, again P is having little bit more as compared to D orbitals. If we compare D and F, then definitely F is having again less shielding effect. Why? Because inner shell orbital electron will not be there for repulsion. If there is no repulsion, electron, and already I have explained, electron always faces two type of forces. One will be the attractive force from the nucleus and the repulsive force from the inner shell electrons. So thus what happens, as we move from S to P, then number of electrons are increasing. So thus what is happening, the inner shell electrons, see I will show one example here. So consider in first cell we know already only 2 electron the capacity of first cell, and then coming to here, that means P6. In second principal cell one we can have 8 electrons. So now just to compare the repulsive force, right? Attractive force is there, already we know. Shielding effect means if the inner shell electron, right? If the inner shell electron will not allow these electrons to come nearer to the nucleus, then that is only the shielding effect. That means it will create one boundary, like by repelling the outer shell electrons. So now one electron can repel only one electron of outer shell. So in inner cell how many electrons are there? 2. But in outermost cell we have 8 electrons. That means among these 8 only 2 are getting repelled. But what about other 6? They are not getting repulsion. So that's why what I am saying is shell is more shielded as compared to P. Why? Because here see 6 electrons. For these 6 electrons we don't have any repulsion. Just what we have, only attraction towards what? Nucleus. So that's why cell definitely size decreases. That is what happening here. Why? Because we have increase in lanthanide. We are at the 4f, but in actinoid we are again moving further, 5f. 5f means one cell is increased. So thus, as the number of cell goes on increases, what happens? Repulsion will not be there, just like this. So that's why they try to move towards what? Nucleus. So that's why here actinoid is having more cells. So more cell means more electron, and the number of inner electrons are less and the outer electrons are more. So thus in such cases, see here there are only 2 electrons, but the outer cell is having 8 electrons. So that's why if the outer cell is shows increased number of electrons, then definitely the shielding effect comes to the I mean existence, right? Why? Because here for any six electron you can take. Sir, S only repel or what? That is not like that. So if there are two means, you can take from one electron from here and one electron from here. It is the case, but in general what we can say, among 8 electrons only 2 are getting repulsion. But what about 6? For those 6 electrons there are no electron to repel out. So that's why they are just moving towards what? Nucleus. So thus if they are moving towards the nucleus, then definitely gradual decrease will take place. That is what happening in the case of actinoids. So your answer will be like this, right? Because of 5f orbitals, answer, because of 5f orbitals, because of 5f orbitals have poorer shielding effect, poorer shielding effect than 4f orbitals, right? 4f orbital belongs to what? Lanthanoid, and 5f belongs to what? Actinoid. So that's why actinoid shows more contraction as compared to what? Lanthanoids. So dear students, this is all about, I thought to complete today itself, but because of time shortage, I have not in the what correct time. I'm not in the correct time, so that's why, because of some family problem. I mean, so that's why I have. It was so late for today's class, so that's why I'm making a small class itself. So definitely in tomorrow's class we will complete RF and then we will move to the next chapter. Thank you.